In this video, we will talk about two new rules of derivative, the product and the quotient rule. So if we have f of x, which is equal 5x squared plus 3x minus 1. So in order to find its derivative, we can derive each term alone because there is a plus and minus in between them. So it will be 5 times 2, it's 10x, plus 1 times 3, it's a 3x power 0, which is 1, and negative 1 is a constant, so its derivative is 0. In this way, it's easily to do the derivative. But we have some function are written in a form of a product, two brackets, 5x squared plus a 3x minus 1 multiplied by 6x minus 3. So here we have two functions multiplied together. So we can expand, multiply 5x squared. Before we do the derivative, we can expand 5x squared multiplied by 6x, 5x squared multiplied by negative 3, 3x times 6x, 3x times negative 3, negative 1 times 6x, negative 1, and like that. But the problem, it's too long process to do it like that. So we will introduce a new rule called a product rule. If we have a function f of x, which is considered to be g of x multiplied by h of x, we have two functions multiplied together and there is a multiplication in between them. How to find its derivative? So f of prime, it's the product rule states that we do the derivative of the first function, g prime of x, multiplied by the second function without doing anything for the second function. Plus, we keep the first function as it is, multiplied by the derivative of the second function. So it means every time we do a derivative for one of them, we did the derivative of g prime by keeping h as it is. Then plus, and this sign is always positive, g of x is kept alone as it is, then the derivative of the second function. So it means we do the derivative every time once. So here if we look to this function, again, it's two polynomial multiplied to each other. So we will consider this is as f and this is as, for example, g of x. So the derivative g prime of x, we will do derivative of the first function multiplied by the second function, plus we will keep the first multiplied by the derivative of the second. Now it will be, so this is f, we will do the derivative of f normally. So 5x squared, we will multiply 5 times x, 5 times 2 plus the power is 1 multiplied by 3, and x will be x power 0. Negative 1 is constant, so 0. Multiplied by 6x minus 3. So we did the derivative of the first, we wrote it in the first bracket, then we kept the second function as it is. So here, let's just make it, since we call it h, so this is times h prime. Plus, now we will keep f as it is, 5x squared plus 3x minus 1 multiplied by the derivative of 6x minus 3. So 6x minus 3, now we will do its derivative and write it down here. So it will be, the power is 1, 1 times 6 is 6, x will be cancelled, 3, it's a constant, so its derivative is 0. So this is our g prime of x using a product rule. So using product rule, we will check here, find f prime of x. We have 2x power 4 minus 3x plus 5. This is our first function, and this is our second function. And there is a multiplication between them. Let's call the first one g, the first one g of x, and the second one as h. Now, if you look quickly, g of x, it has a square root. So this square root will be written as x power half, and this one we will raise the x to the numerator, x power minus 1. So now let's write f of x is equal 2x power 4 minus 3x plus 5 multiplied by the second one, x squared minus x power half plus 2x power minus 1. Now we will do the derivative f prime of x as we said. So this is, we will call it g, this is, we will call it h. So we will do the derivative first for g multiplied by h. We did the derivative of the first function plus we keep the first multiplied by the derivative of the second. So quickly, derivative of g prime, we will drop 4 down, so it will be 8x, and we subtract the power by 1, it's a 3, minus the power here is 1, 1 times the 3 is 3, and if we subtract x, the power of x by 1, we will get x power 0, and this is, we said it in the previous videos, it's always equal 1. 5 is a constant, so the derivative of the constant is 0. Now we did, this is a g prime, now we will multiply it by h as it is without doing anything for it, plus now g will be kept g prime h. Now we will do the second part. G will be kept as it is, so this function, nothing done to it. So 2x power 4 minus 3x plus 5 multiplied now by the derivative of h prime. They said multiplied by the derivative of the second one. So x square, we will drop the 2 down. So 2x power 1 minus, we will drop the half down, x power half minus 1, it's negative half, plus negative 1, drop it down, there is 2, so negative 2x power negative 2. So this is the derivative, and it's unsimplified. We will keep it right now like that. Later on, we will try to expand it and add and subtract the like terms. Finding the equation of the tangent line. So we all know that equation of the tangent line, it is y minus y1 equal m into x minus x1. So y minus m into x minus, if we look to this function, they said find the equation of the tangent line. This is our function y at x equal to 0. So x is 0. Now we need y. So f of y equal f of 0, we will substitute 0 power 4 minus 3 times 0 square plus 2 times 0 into 0 cube minus 2 times 0 plus 3. So the answer, all this bracket is 0 multiplied by the second bracket is 3. So 0 times 3, it is 0. So y is also equal to 0. Now, we need to find, we still need to find the slope. Now, how to find the slope? Usually slope, it is f prime. Now, in order to find f prime, we need to look to our function. Our function consists of two functions. There is a multiplication in between them. There is a multiplication. So let's call this is a g, this is h. And there is a multiplication between them. So we will apply product rule. So it's equal to g prime, the derivative of the first function, times h without doing anything for the second one, plus keep the first multiplied by the derivative of the second. Now g prime, we need to do the derivative of this one. We will drop 4, so 4x, and we subtract the power by 1, minus, we will drop 2 down, so it will be negative 3 times 2, 6x, plus, we will drop 1 down, there is 2, so 2 power x0 is cancelled. Now h will stay the same, plus, now we will write g as it is. Now we are doing g will be kept as it is, times, we will do the derivative of h, we will drop 3 down, so 3x square, minus, the power is 1, we will drop it down, so it's 2, 3 is a constant, cancel. Now easily we can substitute, since they said x is equal to 0. So we will substitute 0. So 4 times 0 cube minus 6 times 0 plus 2 into 0 cube minus 2 times 0 plus 3 plus 0 power 4 minus 3 times 0 square plus 2 times 0 into 3 times 0 square minus 2. So the first bracket, negative 4 times 0 is 0 minus 6. So this one, 0, 0, so it's 2. 0, 0 times 3 plus 0, 0, 0 times, this is negative 2. So it will be 6 plus 0, it's 6. So we got the slope of the equation of the tangent line is equal to 0. 6. So y minus 0 cancelled, 6x minus 0 cancelled. So this is the equation of the tangent line at x equal to 0. Now the second rule in this lesson is called quotient rule. Quotient rule, if we have a function f of x, which is g of x divided by h of x, we need to find its derivative. So quotient, its division, so f prime of x is equal to the derivative of the first function multiplied by the denominator without doing anything for it minus g of x multiplied by h prime of x over. So here it's same as the product. We do the derivative of the first. We do the derivative of the first, keeping the second the same, minus we keep the first as it is. We do the derivative of the second, and there is a minus. In the product rule, there is a plus over h of x, all of it squared. Let's give a quick example. For example, f of x is equal to 5x minus 1 over 2x plus 10. So if we need to find its derivative quickly, according to the rule, so we will say this is g, this is h. So g prime, they said g prime multiplied by h. G prime, we will do the derivative of the first. The power is 1, we multiplied, so 5 power x, 0 cancelled. Negative 1 is constant, multiplied by 2x plus 10, minus 5x minus 1 multiplied by the derivative of the denominator, 2x, it is 2, and the derivative of 10 is constant, over 2x plus 10, all of it squared. So this is g prime, this is h, minus this is g multiplied by h prime over h squared. We can do simplify. So 5 times we can expand. So it will be 10x plus 50 minus. Now 5 times 2 and negative 1 times 2, and there is a minus outside. So it's 10x plus 2 over 2x plus 10 squared. So f prime of x, it will be now negative 10x minus 10x cancel. 50 plus 2, it's 52 over 2x plus 10, all of it squared. This is the derivative using quotient rule. So using quotient rule to compute the derivative. So quotient rule is applied whenever we have a rational function. So let's say this is g of x, this is h of x. The numerator is a g and the denominator is h. So we will apply quotient rule. F prime of x, it's a g prime of x multiplied by h of x minus, we will keep the first as it is multiplied by the second over h of x, all of it squared. So f prime of x is equal g prime. So we will do the derivative of this one. Negative 2 is cancelled because it's constant. So the derivative of x squared, we will drop x2 down. So 2x power 1, it was 2, then become 1, multiplied by h of x, which is x cubed plus 1, minus g prime, g times h prime. We will keep the first as it is, x squared minus 2 multiplied by h of x, which is x cubed. Negative, first we will do the derivative of x cubed and the derivative of 1. Derivative of 1 is constant 0, so derivative of x cubed, we will drop the 3 down and we subtract the power by 1 like that, and the denominator is x cubed plus 1 square. So f prime of x, we will keep x cubed plus 1 square. So we will do the expanding, 2x to power 4 plus 2x, and we will expand those, and there is a minus outside, so it will be negative 6x to power 4 plus 6x squared. Now easily f prime of x cubed plus 1 square, we will leave it. So we have 2x power 4 minus 6, it's negative 4x power 4 plus 6x squared plus 2x, and this is the derivative of this using this rule, quotient rule. Now, a case where the product and the quotient rule are not needed. So if we look here to our function, f of x is equal x radical x plus 2 over x squared. Quickly, if we look here it's a term plus a term, two terms. So we can do the derivative of this one alone, derivative of this one alone, because there is an addition between them. But it needs a little bit simplification. So we need to simplify f of x, this is x power 1 multiplied by x power half, because radical square root, its power is 1 and the index is 2, so x over 2, and plus 2x power negative 2, we raised the x square up. So now we will do the derivative of each one. Before we do the derivative, so f of x, we need to combine these two. So it will be x to the power 1 plus half 3 over 2 plus 2x power negative 2. Now if we need to do the derivative, we will do the derivative here. So f prime of x is equal, we will drop the power 3 over 2 x 3 over 2 minus 1 plus 2 times negative 2, we drop the negative 2 down, there is 2, x to the power negative 2 minus 1. So f prime of x, it's equal to 3 over 2x to the power. Now 3 over 2 minus 1, it's a 3 over 2 minus 2 over 2, which is 1 over 2, plus minus 4x to the power negative 3. So f prime of x is equal 3 over 2, x power half, it's a square root of x, minus 4 over x cubed. So this is our derivative, which we didn't use product or quotient because it's two terms and there is a plus and minus in between them. We can do the derivative easily. Investigating the rate of change of a revenue. So suppose that the product of is currently sells for 25 dirham with an increasing at a rate of 2 dirham per year. So the price now it's 25 dirhams. So the price is 25 dirham and the rate is increasing rate is 2. And at this current price, the customer will buy 150,000 items. So the quantity is equal 150,000 item. But the number of the sold is decreasing. It's negative 8 because it's decreasing 8,000. At what rate is the total revenue changing, and is the total revenue increasing or decreasing? First, we have a rule that states that revenue is equal the price multiplied by a quantity. How come this rule? For example, if we bought Let's write an example here. If we bought 5 items, each costs $2. So the revenue is $2 times 5. So I got $10. The amount, the cost multiplied by the number of the item. Revenue is the function R of t is P of t multiplied by Q of t. Now, in order to find rate, the meaning of the word rate is the derivative. The derivative. So we need to find the rate of the revenue, means we need to find R prime. To do the derivative of this formula, since it is consists of two functions multiplied together and there is a multiplication, we will use a product rule. So R prime of t is equal the derivative of the first function multiplied by Q of t plus P of t multiplied by Q prime of t. Now, how can we find P of t, Q of t? So the price will be P of t, the quantity here, it will be Q of t. Now, increasing rate, it's a derivative, so it's P prime, and decreasing rate, this is Q prime of t. So we'll substitute P prime is 2, the quantity is 150 plus P of t is 25 multiplied by negative 8. So it's 300 my 25 times negative 8, it's 200. So the revenue or the rate R prime of t, it's equal 100,000 dirham per year. So since it's positive, total revenue is increasing by 100,000 dirham. It's increasing by that. Now, example 4.6, using derivative to analyze a golf shot. We have a mass of a ball is 0.05 kilogram stuck by a golf club of a mass m kilogram with the speed 50 will have an initial speed u of m. Let's write it. The function is 83 m over m plus 0.05 meter per second. The speed. So this u represent the speed. Show that u prime, the derivative is positive, and interpret the result in golf terms. Then compare u prime 0.15 and u prime 0.2. First, to compute u prime of m, we will use here a quotient rule because there is division. So quotient rule quickly, it is f prime g minus f g prime over g squared. So m plus 0.05 all of its squared. Now we will do the derivative of the upper function 83m. It is 83 multiplied by m plus 0.05 minus. Then we will write the first function as it is and the first function as it is 83m, and the derivative of the denominator, derivative of 0.005 is 0, derivative of m is 1, like that. So it's equal to 83m plus, we do the expanding, plus 4 minus 83 m over m plus 0.05 square. So u prime of m is equal 83m minus 83m is 4 over m plus 0.04 all of its square. Now let's talk a little bit about this one. So u prime of m, it is 4 over m plus 0.05 square. 4 is always positive because it's an integer, and a quantity square is always positive too. So means u prime is a positive divided by positive is always positive. Now we need to, so it's positive. So according to, if you analyze, we need to interpret the result of the golf in golf terms. So here, u prime, the numerator is constant. We have a denominator only m. So as m increase, the rate of the rate of the speed will get smaller and smaller. 4.15. So this is 4.15. So since m is in the denominator only, so as m increase, rate of the velocity will decrease because they are in opposite direction, one in the denominator, one in the numerator. Now u prime of 0.15, if you substitute it, it's 4.15 over 0.15 plus 0.05, all of it squared, the answer will be 103.75. And we will do the second one, u prime of 0.02, 4.15 over 0.20 plus 0.05 squared, the answer will be 66.4. As we said, as m increase, as m increase, the answer will start decreasing.